This is the screencast for section 5.1, example 2. We're going to be using cofunction identities and odd and even identities. We already know that the sine and cosine graphs look very much alike, just maybe a shift over, or in this case a flip and a shift. Tangent and cotangent, same thing. Secant and cosecant, same thing. Therefore, memorizing these should be pretty simple. Odd and even identities, you already know that an even function means that when you put in a negative x, you get out the original function. So the only two even functions we have in our 6 trig functions are cosine and secant. The rest of them are odd, so when we plug in a negative x, we get out the opposite of what we started with. Now we're going to use these cofunction and odd and even identities for example 2. Example 2 gives us the cosine of theta equals 0.34, and we're supposed to find the sine of theta minus pi over 2. So I'm going to start out with the cosine of theta equals 0.34, basically what I am given. I already know, so my goal is to find the sine of theta minus pi over 2. Well, my cofunction identities shows me that the cosine of theta is the sine of pi over 2 minus theta. So I'm going to, instead of write cosine of theta, I'm going to write its equivalent expression, the sine of pi over 2 minus theta equals 0.34. So I didn't change the value of either side of this equation. The left side still equals the right side because all I did was rewrite cosine in an equivalent way. Unfortunately, our odd and even identity unfortunately our original problem is asking for theta minus pi over 2. We have pi over 2 minus theta. So I gotta first arrange the inside of my sine function to look the same as what my ultimate goal is. So I'm going to take the sine of, and I'm going to factor out a negative. So now I have a positive theta and now minus pi over 2. My odd and even identities show me that sine is an odd function, so a negative on the inside of my sine function is going to result in the opposite of the original version. So I can just move the negative sign to the outside. And now I have something very similar to what the original problem is asking me for, but I'm going to divide both sides by a negative, and I get my final answer that sine of theta minus pi over 2 is negative 0.34. The now try problem example 7 gives me the sine of theta minus pi over 2 equals 0.73. And we're trying to find the cosine of negative theta. Well, let's see. My cofunction identity shows me that the sine of pi over 2 minus theta is cosine of theta, not theta minus pi over 2. Otherwise, I could just rewrite this as cosine of theta, but unfortunately, I have to do a couple more steps here. So I'm going to factor out a negative sign on the inside, which will make this a positive pi over 2 minus theta on the inside of my sine function. Now sine is an odd function, so the sine of negative x is the same as the opposite of the sine of the positive version. Now, let's see, I'm still trying to find the cosine of negative theta. So I'm going to divide both sides by negative 1. So now I have the sine of pi over 2 minus theta, which I believe I have a cofunction identity for. I do. That is exactly equal to cosine of theta. Negative 0.73. So I rewrote sine of pi over 2 minus theta as cosine of theta, and that equals negative 0.73. But I'm trying to find the cosine of negative theta. Well, in my odd and even identities, the cosine of negative theta is equal to the cosine of positive theta, because in an even function, if you plug in a negative number or a positive number, you'll get out the same y value. So the cosine of positive theta and the cosine of negative theta will have the same output, so I don't have to do anything to the right side. So the cosine of negative theta is negative 0.73 if the sine of theta minus pi over 2 is positive 0.73.